and this is how to perform the batch reactor experiment. In this video, we will demonstrate how to determine the kinetics for a reacting crystal violet with sodium hydroxide. The formula for the reaction rate is given by the power law, and it will be used with the performance equation for a batch reactor. In the first part of the experiment, we will find the M and N values, and in the second, we'll discover the values for the activation energy and the Arrhenius pre-exponential factor. Before we begin, we need to make sure that safety measures are in place. This experiment uses highly concentrated sodium hydroxide, which is a caustic solution. Further, crystal violet can stain skin purple. They should only be handled with gloves, and all those participating should wear goggles. The following will be needed to perform the experiment: the Logger Pro, the vernier, the colorimeter, beakers, different solutions of NaOH and DI water, stirring rod and plate, ice, thermometer, and a timer. First, we want to start the software and open up the file in the Experiment 30 folder named Chemistry with Computers. Scale the vertical axis for absorbance from 0 to 0.5, then scale the horizontal axis for time from 0 to 20 minutes. To start the experiment, we'll want to calibrate the absorbance of the colorimeter to the concentration of crystal violet. Go into the interface and click Calibrate Now, then turn the knob to 565 nanometers. Turn the knob to 0% T, then type 0 in the box. Do the same thing for the second calibration point, but instead this time type 100 in the box. Fill the cuvette with 3/4 DI water and close, making sure the clear side is facing the laser. Take 4 samples, one with just DI water and one with crystal violet. The other 2 will contain different mixtures of water and crystal violet. This data is used to define the linear relationship between absorbance and concentration of crystal violet. Next, the reactants are prepared to go into a beaker. Make sure the sodium hydroxide has a much higher concentration than crystal violet, so that the final amount won't change much for the initial amount. Add the reactants to the beaker, then start taking measurements every 45 seconds for 20 minutes. Make sure to note the time, and make sure the absorbance reading is stable before recording it. The reaction is then repeated using a different concentration of sodium hydroxide. Use this data to find the exponents of the power law equation. The second part of the experiment can be prepared while the first is being repeated. To prep for the next step, make 4 vials of 5 milliliters sodium hydroxide, 4 vials crystal violet solution. This part of the experiment will allow you to find the activation energy and pre-exponential factor. Start with 4 pairs of the reactants in separate containers. Make sure the same concentration of sodium hydroxide is used in all 4 pairs. 1 pair will be refrigerated, and 1 pair will be chilled in a freezer. The one chilled in a freezer is pretty much just put on ice, but we use the freezer to make the ice. The other 2 pairs are kept at room temperature. For the first trial, pour the reactants into a beaker. 1 minute after, start recording the temperature, time, and absorbance. The temperature probe will be reading the liquid in the beaker. Repeat for the other 3 samples. This concludes the experiment. Remember to clean all glassware and put everything back where it was at the beginning of the experiment. No one likes to deal with other people's messes.